In this podcast, I'll explain to you how to solve a one-dimensional motion problem. The problem reads, a car is driving at a constant speed of 25 meters per second. The car slows to a stop at a stop sign in 15 seconds, then accelerates back to the same speed in 10 seconds. At what rate did the car speed up and slow down? How far did the car travel? The first thing we want to do is draw a motion diagram. So we have several different time periods. First, the car is traveling at a constant speed. Here's our car. We'll make that the positive direction. And the second time period, a little longer, a little bit later, the car slows down to stop at a stop sign. These are the velocity right here. So we'll give it a dot. Then, a little bit later, here's our car. It accelerates back up to the same speed. So here, the car is slowing down, and here, the car is speeding up. So this is our acceleration. Then we want to sketch a velocity time graph to give us a general idea of what happens before we start solving it. So while it starts at a constant speed, somewhere up on the positive axis, it's going to slow down at a constant rate. It's going to slow down at a constant rate, stop, and then speed up, also in the positive direction, away from where it was going. So it'll look like a V. So let's think about what we know in this problem. We know that the initial velocity, the start of the problem, was 25. And let's concentrate on this first interval first. We know that the final velocity in that interval is 0. Slows to a stop in 10 seconds. 15 seconds. We know the time is 15 seconds. And for that part, we want to know the rate of acceleration. And we also want to know how far the car traveled. So let's concentrate on that first, and then we'll worry about the second time interval. So the equation that we're going to use, we want an equation that has VI, VF, T, and A. So that is VF equals VI plus AT from your list of motion equations. 0 equals 25 plus A times 15. Subtract 25 from both sides. And divide both sides by 15. And putting that in the calculator, we get negative 1.67, and we're expecting it to be negative because we are slowing down. We also want to know how far the car went during that time period. We have several different options to do that. So let's use VF squared equals BI squared plus 2AD. VF is 0. VI is 25 plus 2 negative 1.67 times D. 25 squared is 625, and if we subtract it from both sides, we get negative 625 equals 2 times 1.67 times D. And if we put that in the calculator and divide, we will get 187 meters. Now, that's for the first part of the problem. I'm going to change color, and we can do the second part of the problem. Now it's speeding up after it stops at the stop sign. This time, we know the initial velocity is 0. returns to the same rate of speed. So the final velocity is 25, whoops, not 2.5, that's a 25, meters per second. And the time, this time is 10 seconds. So our acceleration is not going to be the same, it's going to be greater than we had before. And we want to know the acceleration and the distance. So this time, using the same equation, we get 25 equals 0 plus a times 10. So get rid of the 0 and divide both sides by 10. A equals 2.5 meters per second squared, which is positive, and it's speeding up, so that's what we expected. Now let's find our distance. We can use the same equation again. See if I can squeeze it in here. We get 25 squared equals 0 squared plus 2.5 d. 25 squared is 625 equals 2 times 2.5 is 5. So d is equal to 1.5 meters. Let's look back at the question. And it says, how far did the car travel? So the final answer for how far the car traveled would be 187 plus 125, which is 312 meters. So our final answer for distance is 312 meters. Our final answers for acceleration are negative 1.67 and 2.5 meters per second squared. And these are both reasonable answers for a car with those speeds.